Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we're going to look at series circuits. We were looking at resistors and a resistor and a voltage. We're going to continue that, and we're going to look at more than one resistor in this time. So we'll still have a power source, a battery, and for ease let's keep that at 5 volts. And then this time we're going to have more than one resistor. And when the resistors are connected, in fact, let me go ahead and put 3 in here, are connected one after the other where there's only a single path, this is called a series circuit. Series circuit, because the resistors are connected one after the other or in a series, one after the other. So we've got resistors R1, R2, and R3, and in order to find the total resistance in a series circuit, the total resistance is equal to the sum of all the resistors. So in this case it would be R1 plus R2 plus R3. And if we had more in series, it would be the sum of those. Let me give these resistors a value: 10 ohms, 15 ohms, and 20 ohms. So we've got these 3 resistors there. So in this case our total resistance would be the 10 ohms plus the 15 plus the 20. So if we add those together, that gives me, if I'm doing my math right, I hope I am, 45 ohms. So the total resistance of this circuit is 45 ohms. If we remember from our last video that we could solve, or we can find at any point we want or find the current, and remember, if we have the voltage and resistance, we can find the current. Current I is equal to the voltage divided by the resistance, and our voltage is 5 volts and our resistance is 45 ohms, and what that would turn out to be is 1/9 of an ohm, and I don't have a calculator handy so I can't tell you what that is exactly, but you could calculate it out. Now we've got our, I said ohm, I'm sorry, not ohm, 1/9 of an amp. 1/9 of an amp because we're figuring the current. Well, once we have the current through the circuit, I, the current is the same because there's only one path. There's only one way to get from here to here, and since there's only one path in our circuit, let me draw that a yellow marker along the path. I'm not sure if the yellow will show on the video, but that's the only path for the current to flow. Then we can find the voltage dropped across all 3. Remember, the voltage at the resistor, the voltage across all 3 of these resistors, since they're in series, has to total up to be that 5 volts because it has to be the same voltage across. Since the total has to be 5 volts, and we know that voltage is equal to current times resistance, then we can calculate that value. And let me erase part of this so that I've got some room to work rather than go to a new screen. I'm going to keep my 45 ohms. Actually, I don't think I need that. I do need to keep the 1/9 of an amp so that I remember that. And now R1, the voltage across R1 has to be equal to the current I times the resistance of R1. So that's 1/9 of an amp times the resistance of 10 ohms. Well, what does that give us? That gives us 10 over 9. And if we wanted to reduce that, that would give us 1 1/9 volt. Now, if we do the same thing with the 15, that would give us, again, 1/9 of an amp times 15. And that would give us then 1 6/9. And the last one would be, or that would be the voltage on R2, and the voltage for R3 would be, again, the same current, 1/9 of an amp times 20, and that's 20 over 9, so that would be 2 2/9 of an amp. And if we want to check our work, well, 2/9 and 6/9, that's 8/9, plus 1 is 9/9 or 1, plus 1 is 2, plus 1 is 3, plus 2 more is 5, and so that gives us our 5 volts. So if we have a series circuit, we can find the total resistance by summing up or adding up the values of each of the resistors in series, and once we have that, we can calculate the current through the circuit, and once we know the current through the circuit, then we can find the voltage drop across each of the resistors. Now, thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss any future videos, and please check out and subscribe to our other playlists on the Dan on Tech channel.